Okay, so the last part of this topic is just looking at some different problems that we can come across with. So it's basically an application topic, but with all the rules that we've done so far. So let's jump straight in and have a look at an example. Actually, before we even look at the examples, I might just quickly go through this. Now, this basically tells you what to use given which triangles that you have. So, in a right angle triangle, pretty simple. Use simple trigonometry and Pythagoras. Okay, so you look for right angle triangles first. If you've got right angle triangles, do the right angle triangle stuff. If not, then we've got this list. So angle, angle, side. Use the sine rule to find each of the other two sides. Okay, so if you've got two angles and a side, you'll be using the sine rule in this case, okay? Because you can find the third angle by using the angle sum of triangle, and then you can use the sine rules to do the other bits. Okay, side, angle, side. Okay, so for side, angle, side, you can use the cosine rule to find the third side, okay? Or you can use the area formula to find the area. Pretty simple, because when we do the area, A is equal to half AB sine C. The A and the B are either side of the angle that you want. So SAS, perfect for that one. Side, side, side. Use the cosine rule to find any angle. Pretty straightforward. And then we've got ASS, the ambiguous situation, where we use the sine rule to find the unknown angle opposite a known side, and there may be a second solution. So remembering in that case, it was, we're not 100% sure what this triangle looks like. There can be more than one case, so you have to go through those tests. Okay, so that's pretty much a list of which rule to use when. Okay, and so from there we can solve problems. So let's start off with this one. Two people set out from a point P at the same time. Okay, point P, here it is. One travels at 20 kilometers per hour along a straight road in a direction of 32 degrees. Okay, 32 degrees. So if we're starting at north, 32 degrees is about there. Okay, he walks there. Okay, and that's 32 degrees. The other travels at 25 kilometers per hour along another straight road in the direction of 132 degrees. Okay, so if my 90 degrees goes out here, then 130 and 180 is down there, then 132 is probably halfway between these two, give or take. Okay, and he goes that way. And he goes a bit further because he's traveling at a quicker speed, 25 kilometers per hour. Find a distance apart after 3 hours. Okay, so the question becomes, well, how far have they traveled after this time? Okay, let me actually 032 and 132. Okay, so how do we find the distance apart? Well, the distance apart is going to be the distance from where they finish. So from here to here, like that. Okay, we'll call that D for distance. Okay, so what do we know about this triangle besides that? Well, we know that person A has walked up to this point and he's travelled 20 kilometers per hour for 3 hours, so he's travelled for 60 kilometers. And person B, who's at 132 degrees, has travelled for for 3 hours at 25 kilometers per hour. So he's travelled for 75 kilometers. Okay. So find their distance apart after 3 hours. So this distance here. So you might be thinking, well, what can we do to find this one? And we can use the cosine rule, because I think the cosine rule is pretty straightforward. We've got three sides, and we can work out what one of our angles are. So cosine rule, c squared is equal to a squared plus b squared minus 2ab cos c. Okay, and in this case, my p will be my c. Okay, so I can just put a slash c, and a and b work as they are. So in this case, my c is my d. So d squared, the distance squared, is equal to the sum of the other two sides squared minus 2 times the other two sides again times cos of, and now this is where we need to find our angle. So to find our angle, so this angle in here, we know from here, from our northern direction to the first person is 32. We know from our northern direction all the way around is 132. So the difference between the two is what we've got left over. 132 minus 32 leaves us with 100 degrees. So cos of 100. So D is then just equal to the square root of that. put it into our calculator. So the square root of 60 squared plus 75 squared minus 2 times 60 times 75 times cos 100. And that's equal to 103, or 104 if we're going to round. So we'll round to nearest kilometre, 104 kilometres. And we'll put in brackets, rounded to the nearest kilometre. Now, just like with all worded problems, we have to write a sentence to finish off. Therefore, their distance apart after 3 hours is 104 kilometers. Okay, let's have a look at a second example, and we'll do everything in just the one this one, I think, because it's all the same idea. Okay, so an aircraft flies 400 kilometers from point A to B on a course of 40 degrees. Then flies on a course of 160 degrees from B to C. 500 kilometers from A. Calculate the distance BC, and then the bearing of C from A. So let's draw a picture of this scenario, just like we did before. So an aircraft flies 400 kilometers from A to B on a course of 40 degrees. So here's point A here. Directly north is that way, directly east is that way. It's just a bit before halfway, so it's probably about here. So point B, which is 400 kilometers, and in here is 40 degrees. It then flies on a course of 160 degrees. So again, if I make a quick little compass rose up my new point, 160 degrees is almost at 180, but not quite. And we know that he's going to travel for a fair bit. Okay. And we'll call that point C. Now, we also know that he has traveled, sorry, let me just add in there. So that in there is, so from here to here is 160 degrees. Yeah. Okay. We also know that from A to C, it is 500 kilometers. So 500 kilometers from A. Okay, so his new point from A is 500 kilometers. So this length down here is 500 kilometers. Okay. So the question becomes, well, first part is the distance BC. So A, so the distance here. So let's call that distance from B to C, D. The distance. Okay. So now what we need to do is we need to work out, well, what are these angles equal to? Now, what is that distance equal to, and how are we going to solve this one? So what I'm going to do in this case, I'm going to use a different color because it's going to get really messy really quickly. And we're going to start filling in some stuff that we know. Like, for example, I know that this angle here is 40 degrees, and if I actually drew it straight and properly, it makes an alternate angle with this angle down here. So that one's also 40 degrees. I also know, ooh, that's not very straight. Okay, draw another one there. I also know that B is 160 degrees, so from 180 to 160, so this one in here is 20 degrees. So my angle up there is 60 degrees. Okay, so this total angle is 60 degrees. Okay, so that's something I do know. Now, I can also work out what the other angle is, or this angle down here, which we'll call, say, theta. We can work out what theta is, okay, by using the this angle down here, okay? Because we know that the angle sum is 180 degrees. I can calculate what alpha is down here by using the sine rule with this one, and then we can use the cosine rule with the area facts to find what that theta is down there, okay? So, let's start off with the... Oh, it's not working for me right now. Okay, so let's start off by finding alpha. So we're going to go sine of alpha over 400 equals, and now because we know what this ratio is, it's going to be sine of 60 over 500. Okay, so sine of alpha is equal to 400 times sine of 60 degrees over 500. So alpha is equal to the sine inverse of 400 times sine of 60 degrees over 500. So alpha is equal to, and what we're going to do is we're going to put that into our calculator. 400 times sine of 60 equal over 500, and we should get a value of 43 degrees. So that means that this angle in here is 43 degrees. So to find theta, okay, to find theta so that we can now find our distance is just 180. Actually, you know what? Let's do it to 2 decimal places. Sorry, to the nearest minute. And I'll write, nearest minute. Okay, so 180 degrees minus the 60 from above minus my alpha angle. Okay, and so that gives us that theta is equal to, and it should be, putting it into our calculator, 76 degrees and 9 minutes. Now that we've got this value down here, okay, we can then use the cosine rule to work out this last bit. So cosine rule, c squared is equal to a squared plus b squared. Doesn't like doing 2's for some reason. Minus 2ab cos c. So c squared in this case is my d, my distance, is equal to, now 400 and 500. Doesn't matter which one put these in. Just make sure that both of those go in. Not the same one though. Times, and now my cos of my angle that I just found, which was 76 degrees and 9 minutes. So D is equal to the square root of that. Okay. So I would recommend putting all your working out in. Don't try and shortcut it, because that way you might miss something important or might do something that's technically not mathematically correct. So putting that in to our calculator, and we should get an answer of 516 kilometers. Okay. So that's part A. So this distance along here is 516 kilometers. Now part B says the bearing from C to A. Okay. So part B is the bearing from C to A. So we already know what this angle is in there. It's just an extra 40 degrees along from it. So bearing is 40 degrees plus theta, which is equal to 40 degrees plus 76 degrees and 9 minutes. So therefore, bearing of C from A is 116 degrees and 9 minutes. Very good. All right. That's it for this video, and that's it for this first part of trig. We'll be having a look at trig later on in a later topic, where we actually look at a new unit that we're going to be applying to trigonometry. I've decided we're not going to do it straight after, because I don't want to say, here's all this brand new trig stuff. Now, do it all again, but with a different unit. I want to let this sink in for a bit before we do that. So our next topic we're actually going to do is going to be logarithms and exponentials. We're going to have a look at those before we start the main juicy part of the advanced course, which is our calculus. So we're almost there. We're almost starting the fun new stuff. So with that being said, I'll see you guys in the next lot of videos, or maybe back at school.